So matrix decomposition using Python programming. First we'll try to see how we do it. Cholesky decomposition. So these two are default libraries. NumPy, I am using alias name np, and I am importing another important function, uh, linear algebra, linalg. So how to find it out? See, I have a equal to np dot array. I have given the same problem which we have solved. So a 4 12 minus 16 12 37 minus 43. I have given this. It's just one command here. What is this? Sorry, right? Oh no, something has gone. Let me write the matrix again. A equal to np dot array of, in this I have three separate. Yes, so the elements were uh, 4 12 and minus 16 12 37 12 comma 37 minus 43, and third one minus 16 minus 43 98. So this is my I will exclude this. NP is not defined. I have to run this first, right? So this is done. Now I have defined a matrix A. So I add a new text here. So I write L equal to np dot linear algebra alg dot Cholesky of matrix A. So this will convert the given matrix into, it will find out L for me. Now if I try to print L, see, it gives me the same thing, 200610 minus 853. So just using this function, np L equal to np dot linear algebra function dot Cholesky of the matrix A, it gives you the L. So you know L into L transpose, you just write transpose of it, you get the matrix. So you are able to decompose a given matrix A into two separate matrices, L and L transpose. Similarly, we'll see singular value decomposition. Take a small, this is one step, because in SVD we have to calculate eigenvalue and eigenvectors. So I have taken one example here. Let's take problem which we have solved in the explanation. Right. So let it be 2 and 2, and here minus 1 and 1. So this is, I have one more array B, array equal to 2 minus 1, 1, 2 by 2. I'll just execute this. See how to calculate eigenvalue and eigenvector in a single step. Eigenvalue and EV equal to np dot linear algebra function dot eig of B. If I run this, it is calculating both eigenvalue and eigenvector in a single go. So this EV is giving me two separate matrices. One is a vector eigenvalues, other is eigenvectors for those. You see, you got here eigenvalues equal to this is what, this is one eigenvalue, this is another eigenvalue. Eigenvectors, first one is this, and for second one it is this. Okay, eigenvalue and eigenvectors. So for this we were doing single value decomposition. So B is our matrix. Now see what we have to find out in SVD. We have to find out three separate matrices, U, sigma and V transpose. So I wrote V S V H equal to NP linear algebra SVD. This is the function name, SVD of B. So is it a full matrix or not? It is asking, because we know we said that EVD can be SVD can be used even for rectangular matrices as well. So whether that matrix is full or not, that I'm giving here. Yes, it's a 2 by 2 matrix. So need not do the A transpose A part here. So I'll just execute this. So it is computing, you see, U array, you get U, you want sigma, you get this, and you want VH, you get this. So you got all three here. You may ask me, sir, here why S is like this. So this is square root of eigenvalue 1, square root of eigenvalue 2. Okay, so this is also an array, but it's giving in a single form. You have to write in a matrix form. So USVH. So SVD is the function name. With this, you can find out those three matrices. So it's very, very easy to do whatever we have been solving on paper. It is different. You just use EIG to get the eigenvalue, eigenvector. You use Cholesky function, you get the L matrix, or you use SVD, you get the those three matrices. Okay, so it's very easy to do in Python, but still it is very important to know how we do it manually.